Hi guys, this is Saurav here and welcome to online Pathshala, Vedantu's initiative to make education outreach to be as much as possible to everybody as possible. So this is Saurav Goswami here and we are in the physical chemistry series. We are doing a physical chemistry series for 12th standard students, and in this series we are currently doing the topic of liquid solutions, or you can call it colligative properties. Okay, hello guys, I can see a lot of people seeing me right now, and if you're able to see me and if I'm audible perfectly, please do say yes. This topic or this session is the third lecture in the line of the other topics that we have conducted until now. So we have conducted topics which are vapor pressure. We have also conducted topics we have also conducted a lecture on concentration units. Okay, Preetham Mandal, it's a very easy topic. It's like one of the easiest topics in physical chemistry. Now this session is about Raoult's law, and we would be talking about what is an ideal solution. Okay, so this session is an extension of whatever we had discussed the last class, that was vapor pressure. And if you remember, vapor pressure helps us identify what is the tendency of the solvent molecules to escape into the vapor state. Okay, so यश वाग हम लोग इलेक्ट्रोकेमिस्ट्री बाद में करेंगे, पहले तो अभी लिक्विड सॉल्यूशन चल रहा है. We'll first finish liquid solutions, then we'll move to electrochemistry or other topic. Rest assured, we will be covering all physical chemistry topics of the second year, or you can say 12th standard. Okay, so let's start with what is Raoult's law. Okay, ये एक law है, so there is no violation as long as the preconditions or prerequisites are met. So what is Raoult's law? Raoult's law says that the vapor pressure of a particular solution, vapor pressure of a particular solution is the sum of the pressures due to vapor pressure due to the contributing solvents. Let's say we prepare a solution of two liquids A and B. तो हम क्या कर रहे हैं? We are preparing a solution of two liquids, liquid A and liquid B. You can see they are represented by different colors. So liquid A is black, liquid B is red, and when we mix together we have some molecules of liquid A, we have some molecules of liquid B. Now when they will evaporate, then in the vapor region we would have some molecules of liquid B, so liquid B vapors. Also we would have liquid A vapors. So in the vapor phase there would be contribution from liquid A as well as liquid B. ऐसा नहीं होगा कि सिर्फ liquid A evaporate करेगा, ऐसा नहीं होगा कि सिर्फ liquid B evaporate करेगा, दोनों मिल के evaporate करेंगे. Okay, now when they would evaporate simultaneously, then if I want to calculate how much is the contribution from liquid A in that evaporation chamber, in that flask, then we have to use Raoult's law. Raoult's law ये कहता है that the vapor pressure of any component will be directly proportional to the mole fraction of that component. इसका मतलब if the solution is being mixed in a ratio, let's say some mole ratio of 1:1. So 1 mole इसके present है, 1 mole इसके present है, तो mole fraction क्या हो जाएगा? 0.5 for liquid A, 0.5 for liquid B. Then the vapor pressure due to liquid A will be proportional to the mole fraction of liquid A. Vapor pressure of liquid B will be proportional to mole fraction of liquid B. Okay, it's a very easy representation. Let's understand it mathematically. So let's understand it mathematically. Let's say there are two volatile liquids. Now when we are making this solution, we are making a solution of two volatile liquids. I am not making a solution of Does it matter if it is impure? Yeah, it does matter if it is impure. We are taking pure so that the nature of interactions are uniform. Okay, we are making this pure so that the nature of interactions are uniform. अगर impure लेंगे then क्या होगा कि आपने कुछ मिला दिया उसमें. So we are taking a binary solution. What kind of a solution are we taking? We are taking a binary solution. This ideal solution is binary. Why binary? Because there are two components. There are two components. Now let's say this liquid and this liquid are mixed together to create a solution. In that scenario, we will be having certain values. In that scenario, we'll have certain values. Let's say vapor pressure of liquid A, PA, is within this solution. This is for the solution, and PB is also for the solution. जब हमने मिलाया, okay, when we mix the liquids, we also have certain mole ratio, and from the mole ratio we calculate the mole fraction. If I calculate the mole fraction and we know the ideal vapor pressure means we take the solvent in pure state and allow it to evaporate at a certain temperature. So at 25 degrees Celsius, there could be a certain amount of vapors. At 25 degrees Celsius, there could be certain amount of vapors within the pure liquids, within the pure liquid chamber, and that will turn out to become the ideal vapor pressure. So that is the ideal vapor pressure P0A and P0B. Now how would we write the outcome? इसके outcome को लिखने का तरीका क्या है? The outcome would be written like this. So it's very simple. Method is very simple. If I use Raoult's law, I will say that the total pressure will be equal to the pressure due to A and pressure due to B. दोनों liquids evaporate किए हैं. Both liquids are evaporating. Whatsoever amount of pressure is generated by the evaporating molecules of A and whatsoever pressure would be generated by evaporating molecules of B, the sum of these two will become equal to total pressure. The sum of these two will be equal to total pressure. Papia, I will get to your question a little later. Let me explain this first. So how would I write PA? From Raoult's law, I know that PA is proportional to mole fraction of A and PB is proportional to mole fraction of B. Okay, so PA will be written as mole fraction of A. What is the proportionality constant? Is the ideal pressure of A. Pressure of B. That is what we would be getting over here. Okay, I will explain. Yes, okay, ठीक है, उस पे हम जाएंगे. So this is our total pressure. This is our total pressure. यही expression आपको याद रखना है. This is our total pressure. Total pressure is pressure due to A, pressure due to B, which is pressure due to A is proportional to mole fraction. If I want to make it equal, it is mole fraction times the ideal pressure. Mole fraction times the ideal pressure. How would I further simplify this? Simplify करने का तरीका बहुत easy है. If I take mole fraction, can you tell me the mole fraction sum will always be equal to 1? Mole fraction का sum always equal to 1 दिया गया है. Soumya Dikshit, we'll get to that later. Okay, we'll get to that. It will always be equal to 1. So I can write 1 minus chi B, 1 minus chi B. So what I have done is I have replaced chi A and written it as 1 minus chi B. I will simplify it in this form. In this case, I just need to know mole fraction of only one liquid and ideal vapor pressure of both the liquids. Okay, so it's a very simple explanation. Now, some people are asking that what would happen, sir, if I take a non-volatile solute? We would get that too in the next class, but I will tell you one important. Pratiksha, how can it be? Why I am pronouncing Kai? It's not X, it's Kai. Okay, it's Kai. Okay, it's a Greek alphabet, so its name is Kai. Now, why isn't the value greater than 1? The reason why isn't the value greater than 1 is because mole fraction, let's say I have 1 mole of A and 1 mole of B. What is the mole fraction of A? Chi A will be equal to moles of A by the total number of moles, 1 by 2. What will be mole fraction of B? Chi B will be 1 by 2. If I add both of them, it will be 1. It will be 1. If I take 3 and 4, so this will become 3 by 7 and this will become 4 by 7. It will eventually in all cases will be equal to 1. Okay? It will always be equal to 1. So we do not need to worry about this part. This is gonna always be equal to 1. Okay? Chaliye. Now somebody is asking that, sir, what would happen if I take a non-volatile solute? Okay, इसको मैं अभी explain कर देता हूँ, बहुत simple सा है, but we will do a more detailed explanation in the next class, in the next session. So our equation is something like this. Our equation is something like this. Mole fraction is always less than 1. Yes, sum of mole fraction will be equal to 1. So let's say I have a solute. Solute is B and solvent is A. Suppose मैंने water में नमक डाल दिया. If I take water and add salt to it, let's say BB NaCl and A is H2O. When I mix both of them, I mix both of them. Sodium chloride I know is non-volatile. When I mix both of them and keep them in a container. Now you will have some molecules of sodium chloride also dispersed all the way onto the surface, and so the number of molecules of H2O present on the surface will decrease. Now NaCl, since is not evaporating, the amount of H2O molecules that will go into the vapor state will be a lot less than what it was going when it was only pure H2O. Okay, when it was only pure H2O. In that case, what we will do is, I will take the P0 of B as equal to 0 and P0 of A will remain as it is. Okay, so I take P0 of B as equal to 0. Okay, so what will I get? PT is equal to PA0 plus, PA0 minus PA0 chi B. PA0 chi B. In this equation, I remove PB0 because P, it's a solute. Solute का कोई vapor pressure नहीं होगा. Now, this is ideal. The total, initially it was P0A. Initially it was P0A. You add some solute. Now the pressure becomes P0A minus P0A chi B. Is the pressure decreasing? Is the vapor pressure decreasing or increasing? When you have pure solvent and now when you add solute, is the vapor pressure decreasing or increasing? Simple mathematics से देख के बता सकते हैं क्या हो रहा है? Please tell me in the comment section that it is decreasing, isn't it? It is decreasing. So if I increase the amount of solute, अगर मैं chi B को increase करता रहता हूँ, if I keep increasing the amount of solute, then what would happen? The total pressure will keep on decreasing. So the vapor pressure of a solution which contains a non-volatile solute and a volatile solvent will always keep decreasing as we increase the amount of solute. So what does the vapor pressure depend on? The amount of solute which is present. अगर solute कम है तो vapor pressure ज़्यादा रहेगा, अगर solute ज़्यादा है तो vapor pressure कम रहेगा. Can a partial dropper? I really don't know what a partial dropper is. I haven't ever. Okay, fine. So if this is understood, let's move on and take up a very, not so very challenging, I don't find it challenging, but let me take a part which talks about in which cases can we use ideal solution. So, in which case we can use Raoult's law, sorry. So we can use Raoult's law in the scenario where we have an ideal solution, where we have a ideal solution. Ideal cases में हम इसको use करेंगे. Now ideal क्या होता है? What is the meaning of ideal? Okay, what is the meaning of ideal? In case of a solution, ideal has the same meaning as what ideal has in gaseous state. In gaseous state, the meaning of ideal is that there is absolutely no force of attraction and the volume occupied by molecules is very, very less, infinitesimally small. Now, ideal solutions mean two such solvents which when mixed with each other, would not perceive any difference in the nature of attraction. For example, I take benzene and I take toluene. Okay, I take benzene and I take toluene. I take a sample of benzene in which benzene has a lot of benzene molecules around it. I take a sample of toluene in which there are a lot of toluene molecules around it. Now when I mix them together, if benzene fails to identify that toluene molecule uske आसपास present hai, then it becomes an ideal solution. And why it will fail to identify? Because the nature of forces, the nature of forces that are acting between two benzene molecules. So one benzene and two benzene molecules, the nature of forces that are acting between two toluene molecules is the same as the one which is acting between a benzene and a toluene molecule. Okay? प्रियांशु, अभी हेनरीज लॉ तो आया नहीं है, तो हम हेनरीज लॉ के बारे में भी चिंता क्यों करें? Okay, can two ideal solutions chemically react? No. Okay, ideal when I think you tried to mean that two solutions, a solution in which two solvents, these two solvents should mix with each other or react with each other or not. So ideal solution, how would we do that as an assessment if it is given in an examination? तो जो nature of interaction रहेगा, which will be almost alike, it will be like the next homologue in the scenario, in the series. For example, the next homologue in between, if we compare hexene, is heptane. Homologue is a difference of what atomic number, what is the total mass difference when we take a homologue? There is a CH2 difference, that means a 14 gram का difference आ जाता है. Okay, so similar, homologues are similar. Bromoethane, chloroethane, nature of compound is almost similar. Bromine and chlorine बोलो halogens हैं, and ethane unit भी alike है. Okay, benzene and toluene look like they are homologues. CCl4 and SiCl4 both are non-polar. Almost the same kind of interaction. Chlorobenzene and bromobenzene, almost the same kind of interaction. Ethyl, bromide, iodide, not a big difference. So in reality, if I would say these liquids exist, Okay, these liquids exist. In reality, ideal जैसा कुछ नहीं होता है. However, the least amount of deviation from Raoult's law will be observed for them. Okay, the least amount of deviation from Raoult's law will be obtained for them, and that is the reason we call them near ideal or ideal. Near to ideal or ideal बोल देते हैं. ठीक है? Is that clear? Later in the series, we will talk about what are non-ideal solutions. So when we take, let's say, HNO3 in water, ethyl alcohol in water, they'll form non-ideal solutions. And how would we identify what is the meaning of non-ideal? Okay, non-ideal is very easy to identify. Ideal identify करना और ideal के बारे में ये सोचना कि ideal means exactly ideal, all these things are true. No, there is least amount of deviation. Okay. पोलार एंड नॉन पोलार, इसमें अभी कुछ नहीं आ रहा है, दोनों की पोलैरिटी ऑलमोस्ट सेम है. ठीक है. लेट्स टॉक अबाउट समथिंग विच अ लॉट ऑफ स्टूडेंट्स फाइंड डिफिकल्ट. सो व्हाट वी वुड ट्राई टू डू इज वी विल ट्राई टू ग्राफिकली रिप्रेजेंट Raoult's law. Okay, we will try to graphically represent Raoult's law. Now for the graphical representation of Raoult's law, what I'm gonna do is I am going to take a solution made by two solvents A and B. A solution made by two solvents A and B. Okay, ये दोनों solvents हैं and this is the ideal solution. ठीक है, this is the ideal solution. Now मान लेते हैं solution में mole fraction of A is expressed as chi A and mole fraction of B is expressed as chi B. Okay, it's a binary solution. Mole fraction of A is expressed as chi A, mole fraction of B is expressed as chi B. Now what we are going to do over here is we are going to plot vapor pressure with respect to mole fraction. Vapor pressure with respect to mole fraction. ठीक है, we are trying to plot vapor pressure with respect to mole fraction. Now it is very important to know कि whose vapor pressure is higher. So I will give you an additional information that A is more volatile. This is the order of volatility. A is more volatile than B. If A is more volatile than B, can we say that the vapor pressure of A will be higher than B? Ideally, that means if I take pure solvent A, then A will evaporate faster, create more vapors, and B will create less amount of vapors, isn't it? This condition is given in the exam. A is volatile than B, or vice versa. Yeah, it will be given. It will be given. Okay, it will be given. Okay, so it can unless and until you know that one is more volatile, one is less volatile, you cannot plot this graph. Okay, so I will say that vapor pressure of A will also be more than vapor pressure of B. ठीक है? Vapor pressure is A is more than the vapor pressure of B. Clear? Now let's say we take a pure solvent A. Mole fraction of A is 1 and mole fraction of B is 1. I am taking two ends, and this end, this origin represents a solution, a situation where there is pure A, where there is pure A. If I take pure A, then the vapor pressure will be somewhere over here, and this value will be P naught A, isn't it? If I take pure B, then the vapor pressure will be somewhere over here. Why it will be like this? Why it will be like this? Because I know that for pure solvent A, vapor pressure of A is higher than that of B. If I take pure solvents, then vapor pressure of A is higher than that of B. Okay? Is it clear? Is it clear? Now, vapor pressure is greater than more of vapor pressure of B. Now, if I, so at this point I can write XB is equal to 0. At this point I can write chi A is equal to 0. Okay, chi A is equal to 0. Now if I keep on increasing chi B, अगर मैंने A में B add करना शुरू कर दिया, then B evaporates to a lesser extent. So the vapor pressure will keep on decreasing. Vapor pressure will keep on decreasing until B का amount पूरा equal to 1 हो जाता है. Okay, so it will keep on decreasing. I'm sorry, this has to be straight line, so let me draw it again. This will keep on decreasing, and if I start adding A into B, then what will happen? I will get a plot like this. I'll get a plot like this. Okay, now why I would be getting a straight line? This has to be a straight line. Okay, so straight line होना चाहिए ये. ठीक है. Now why it should be a straight line? Why it should be a straight line? If you remember, what is the relation between vapor pressure of B with respect to its mole fraction? What is the relation? That vapor pressure will be dependent on the mole fraction. Don't you think that it will, if I change this linearly, this will also change linearly? Y equals to x के जैसा plot आ जा रहा है आपका. ठीक है? Now, what will be the total pressure? What will be the total pressure? इसको calculate करना बहुत easy है. इसको calculate करना बहुत easy है. You can do it graphically. In a graph paper, you do this and take some random values of chi A and chi B. So आप कुछ random values लेके भी इसको solve कर सकते हैं, but for the sake of convenience, I'll show that what will be the total pressure equal to. The total pressure will be this red line. The total pressure will be equal to this red line. So this represents, so let's say this represents P total this represents PA, while this represents PB. You can solve this graphically. What you do is you take chi A and chi B, ऐसे एक दो values ले लीजिए, and you take this as 0, this as 1, this as 0.1, this as 0.9, this is 0.2, this is 0.8, so on and so forth, until this is 1 and this is 0. Okay, आप इसको कीजिए ऐसे कि एक ग्राफ पेपर लीजिए और ये सारे वैल्यूज आप ले लो. Assume that P0 A is 100 and P0 B is 50. ये मान लो, assume कर लो. You assume that this is the scenario. Now you try to draw, you try to observe what will be the vapor pressure due to A in this scenario, what will be the vapor pressure due to B in this scenario, what will be the vapor pressure due to A in this scenario, what will be the vapor pressure due to B in this scenario, using this equation, because PA will be also equal to chi A, P0 A. Now once you are done this, try to calculate the total pressure and total pressure को points बनाते जाइए. When you try to fit a line through that curve fitting अगर आप करोगे, you will get this line. Okay, so you can do this graphically as well on your own. So you do not have to remember this plot. It is a very easy plot. ठीक है? So if you have understood this, please write yes, okay, so that we can move forward. You'll get a straight line, okay? You can do it graphically, paste it next to your study notes so that कि आपको याद करना नहीं पड़ेगा, okay? So let's try to solve some questions. Let's try to solve some questions. The first question is this. So I hope that you have a pen and a paper ready with you. You have a pen and a paper ready with you. Let's try to solve some questions. The vapor pressure of pure liquid A is 70 torr. So it is given that P naught A is 70 torr. Forms an ideal solution with another liquid B. P naught B is to be calculated. I know that P total is 84. What is known that chi A is 0.8 and chi B is 0.2. Okay, because mole fraction of B is given as 0.2, so chi A will be 0.8. Okay, you do not have to convert. You do not have to convert. You can get the answer in terms of torr. Okay, you can get the answer in terms of torr. So what will be the pressure? I know that total pressure will be equal to PA plus PB, which is chi A times P naught A plus chi B times P naught B. Incorporate the values. This will be 84. This is 0.8. P naught A is 70 plus chi B, which is 0.2 P naught B. You can get the answer from here. What is the answer that you are getting? What is the answer? Please tell me what is the answer that you are getting. 140. Let's see, 84 minus 0.8 times 70, that is 56. That turns out to be how much? 28, if I'm not wrong, yeah, 28 divided by 0.2, yep, 140. Answer should be 140, 140, not 14, 140 होना चाहिए answer. Yep, the answer is 140. So I've also written the solution over here. Answer is 140. Very simple question, very, very simple. ठीक है, चलिए next question. Liquid A and B form an ideal solution. Liquid A and B form an ideal solution if vapor pressure of pure A and B are 500 and 200 Newton per meter square respectively. So P naught A is given as 500. Okay, P naught B is given as 200. Find the vapor pressure of the solution containing 0.2 mole fraction of A. So chi A is 0.2, chi B will be 0.8. So P total will be this times that. So 500 times 0.2 will be 100. 200 times this will be 160, I guess. 360 answer होना चाहिए. Answer should be 360 Newton per meter square. Sorry, 260. Sorry, 260, not 360, 260. Yep, it will be 260. So it's a very, very simple scenario. It's a very, very simple scenario. Raoult's law पे अगर आपके questions आ गए तो मतलब आपकी चांदी है. ठीक है, बहुत easy सा सवाल बनता है, कोई दिक्कत नहीं. P नॉट दिया रहेगा, P नॉट दिया रहेगा, one of them would not be given. ठीक है, चलिए. Okay, so 260 Newton per meter square. Okay, एकदम बोर्ड लेवल का सवाल आता है. इवन JEE में भी इतने डिफिकल्ट, मतलब there are so many different things in liquid solution to be asked that they generally don't give Raoult's law questions, but if they do give Raoult's law question, it's very simple to calculate. Now interesting aspect is example 3. Okay, example 3 थोड़ा challenging है. थोड़ा challenging इसलिए है, example 3 solve करने से पहले मैं आपको एक context दे देता हूँ. Okay, and on the basis of that, let's try to solve question 3. Okay, so suppose I'm just giving you an idea. Suppose I have two liquids A and B. Liquid A mole fraction is 0.2. So chi A is 0.2, chi B is 0.8. Assume that, or let's take some simpler values. Chi A is 0.5, chi B is 0.5 in solution. Assume that chi A is 0.5, chi B is 0.5. एक example हम ले रहे हैं before solving this example 3. Now P naught A is, let's say, 100 and P naught B is, let's say, 50. Assume that P naught A is 100 and P naught B is 50. What will be the total vapor pressure? Can anybody tell me what will be the total vapor pressure? कितना होगा vapor pressure for this solution if both of them are mixed? What will be the vapor pressure? 75. Very nice. Vapor pressure will be 75. Let's say ये mm में है. This is mm of Hg. So this is also mm of Hg. Pt will be 75. Now question आपसे ये पूछा गया. Let's say you are being asked this question that what is the mole fraction of A in vapor state? This is mole fraction in liquid state. जो mole fraction आप Raoult's law में use कर रहे हो, that is for whatever moles fraction that you are getting for the solution. What if you are being asked that what is the mole fraction in the vapor state? So remember, mole fraction in vapor state. If I am asked to calculate mole fraction in vapor state, I will use, very good Pratiksha, I will use Dalton's law of partial pressure. What does Dalton's law say? Let's say there is a container which contains 5 atmosphere of a gas A and 3 atmosphere of gas B. Okay, the total pressure is 8. So what is the mole fraction of A? Mole fraction of A will be pressure due to A by total pressure. That will be 5 by 8, and mole fraction of B will be how much? 3 by 8. ठीक है, 5 by 8 and 3 by 8. यहाँ पे मैं आपको कोई न्यू फॉर्मूला नहीं दे रहा हूँ, बिकॉज न्यू फॉर्मूला यूज करने की जरूरत नहीं है. इट्स नॉट इंपॉर्टेंट. इन बुक्स दे गिव, बट in my opinion it's not necessary. So what I will do is, I know total pressure. I will calculate pressure due to A. What is the pressure due to A? 50, isn't it? Pressure due to A is 50 because it is 0.5 times 100. And pressure due to B is 0.5 is 25, isn't it? Is that understood? 0.5 times 50, isn't it? So pressure due to A is 50, pressure due to B is 25, total is 75. So what will be the mole fraction of A in vapor state? That will be 50 by 75, and mole fraction of B in vapor state is 25 by 75. 25 by 75. So 50 by 75 will be equal to how much? 50 by 75 will be equal to how much? सौम्या आप किस सवाल पे हो अभी? 50 by 75 will be equal to how much? So it is 10 by why it should be 22? It should not be 22. Why should it be 22? It should be 2 by 3, and this would be 1 by 3. Okay, This would be 2 by 3 and this will be 1 by 3. Now, which is present to a greater extent, if the mole fraction of A in vapor state is 2 by 3 and this is 1 by 3, that means which is present to a greater extent in the vapor state. कौन सा ज़्यादा present है? A ज़्यादा present है या B ज़्यादा present है? A is present to a greater extent. Okay, A is present to a greater extent. Now, let's do a reverse thinking. पीछे चलते हैं थोड़ा. Vapor pressure of A is 100. That means A is more volatile. A is more volatile. B is less volatile. So from common sense or common idea of things, I can say that if I mix A and B, A being more volatile should produce more vapors as compared to B. That is also observed mathematically as well. Even if we take equal amounts of them, A is producing more vapors, B is producing less vapors. Okay, so that is also proved mathematically. So whatever common sense that you are applying is also backed by a mathematical result. Is that clear? So whichsoever is more volatile will produce more vapors even though the amounts of substances taken in the liquid state is equal. Okay? So this question turns out to be your homework because I have explained what you have to do. So this example 3 is your homework. Okay, so I hope you have understood Raoult's law and ideal solution, and इसको आप नहीं भूलेंगे आगे, because we will be continuing to use Raoult's law, ideal solution and these terms a number of times in the forthcoming lectures. Okay, so with this I, Saurav Goswami, take leave, and we will meet in the next session where we would be discussing relative lowering of vapor pressure. Please do join me in the next session because you would not want to miss that. From there questions do come. Okay, so fine guys, so chaliye, all the best and we'll meet each other the next time. Bye bye.